Oh, okay.
And my buzz was going so, and then my dad has both. So
Good. Now, whenever you have a unit circle is used for finding trig ratios. If this is theta, your x coordinate will be cos theta and your y coordinate will be sin theta. So the coordinates give you the cos theta and the sin theta respectively. So when they ask you this question, state the exact coordinates of A, B, C. So what are coordinates of A?
26.
No, cos 26,
Sin 26.
sin 26. This is exact. When they say exact value means you leave it as cos 26, sin 26. Okay, for B,
Cos 146, sin 146.
C,
Cos 189, sin 189.
cos 199 it is, sin 190. Okay. And then they say part 2, use your calculator to give the answer to 3 decimal places. So you basically use your calculator and you write
And
this
you put in cos and then
cos 26 and sin 26.
Can you just see that? Can you
Yeah.
see that? Where?
26 degrees.
Okay.
So with the angle in degree, your calculator has to be in degree mode. So be careful, otherwise all your answers will go wrong. So cos 26, mine is also in radian mode. So set up, go to angle, degree, make it, and then your cos 26. That's how much? Tell me.
0.4.
0.899. And sin 26?
0.4.
0.438. Yep. So similarly, all the sums are similar. It's minus also the same way it works. So cos of, I'm just writing it so that if you have any question in your mind, it gets settled. 0.707. 0.707 decimals.
Oh.
So and this is your root 3 upon 2. 0.8 866. Copy and complete a table. Use your calculator to evaluate the trig ratios and write them exactly. So you can have to sin 30 is half.
Sin 30 is minus 0.9.
Sin 30 half. Then your calculator has to be in degree. I'm telling you angles and degrees, so you don't have to change that. Half. Sin 45 is 1 over root 2.
2 over root 2.
2 over root 2. Root 2 over 2.
Root 2 over 2.
Which is same. Which is same as 1 over root 2. 60 is
3 over 2.
root 3 over 2. 135?
Same thing. Root 2 over 2.
Root 2 over 2. 150?
1 over.
Half.
Minus root 3 over 2.
Minus root 3 over 2.
Minus root 2 over 2.
Minus root 2 over 2.
I'm going to do cosine.
Cosine is cos. So root 3 over 2. Root 2 over 2. Half. Minus root 2 over 2. Minus root 3 over 2. 240 is same as 60.
Minus
60
half.
is minus half. All silver teacups. Unit circle where I am using. And 315, 45. 45 all silver teacups are positive. Root 2 over 2. 9b, start. Which of the graphs show periodic behavior? Is there a graph that replicates? Can you see this graph? Is it replicating? Is this replicating? So yes, it shows a periodic behavior. Here, is there a particular graph which replicates? This one? This one is replicating? Yes, periodic. C is also replicating. This part, this is like 1 unit. Till here.
Even E.
So this is replicating this only.
And F.
This is replicating, yes. This is replicating?
Yes.
Yes.
F is also.
F is also replicating. Yeah, you have this. This is 1
G is
unit.
also.
G is replicating. No. Replicating in the sense that, the same graph should come. If I draw a y value, I should get, for the same value, I should get a different x and the same one.
Okay. H no.
So replicating in that way. So for y, there should be the same x. Paul spun the wheel of his bicycle. The following table values show the height above the ground of a point of wheels at various times. So the time is given and the height of the wheel above the ground is given.
The graph of height against time, but which one are you using?
All, the entire thing. So when you're doing this, you go to statistics, enter, you put all these values in list 1 and list 2. So delete all, F1, delete all, F1. So in list 1 you put in the value 0. So once you enter it, you go to set. One second, let me show it from here. Go to set. Now the graph, which is the graph type, you take scatter. Correct? Your X list.
1 and.
I put 1 and, for me it's 1 and 2. For you, whichever list you put in, you
I
type.
did 1, 2, 3, 4.
Oh no, you have to put all in the same list. You have to put all, it's like the same table which is continued on the next line. Acha, acha, I know what you're doing. Graph, scatter, use list 1, list 2, enter, correct, and graph 1.
Graph 1.
Correct?
How do I go to graph 1?
Plot a graph of height against time. Is it reasonable to fit a curve to this data, or should you leave this at discrete points? Obviously fit a curve. Correct? You can't leave it as discrete points because time is continuous variable. Time is continuous, no? So you'll be able to fit in a curve. Okay? Then is the data periodic? Is the data periodic? Yes. The data is periodic because you can see that replication thing which is there. What is the equation of the principal axis?
Max plus min over 2.
Very good. Oh. Achha, now what is the max value? Max y value.
64.
What's the minimum y value?
0.
So equation of the principal axis is y is equal to max plus min over 2.
20.
So y is equal to 32. That's the equation of the principal axis. What is the maximum value?
64.
Maximum value is 64. What's the period? Now, where is it 64? So if you use trace now, one second. Trace, we can't trace any of this graph, any of these points. This point I want to select. Where is 64 is max?
Yeah.
64 is max at what time?
1.
Then your 64, this is close to 64, 63.
3. So 2.
3. So what's the period?
2.
2. So basically it's like this. This graph is, it's like this.
Okay. That's easy.
So this is maximum at 1. This is maximum at 3. So the period is the difference. So period is equal to 2 seconds. Correct? Max and max. The time you take. Amplitude.
Max minus min.
Amplitude is max minus min over 2. Max minus min over 2. So that's how much?
32.
32.
Why did you take max?
Below is the accurate graph of y is equal to sine theta.
Yeah.
Find the y-intercept of the graph. What is the y-intercept of the graph? Y-intercept is 0.
0.
See here, where does the graph cut the y-axis? Look. So y-intercept is 0. It cuts here now.
Yeah.
Find the value of theta when your sine theta is 0. So when your sine theta is 0, you draw this line over here. This is your 0 line. Sine theta is 0, it is a horizontal line. Where does it cut the graph?
0,
0,
180,
180, 360, 540, 720. Okay. Sine theta is minus 1. So I draw sine theta is minus 1. So I draw a graph over here. So what does that mean? What does theta mean?
0.
0. Not 0. Where? It's cutting the graph. You have to see where it cuts the graph.
270.
Where else?
630.
630. Half. So draw over here.
So it cuts the graph at
This.
something,
This.
something.
What is that?
Let's say 70.
30, na? 30 this is. Because the 90 is divided into 3 parts.
30, 170.
No. 150, na? This is 30, na? 1, this is 30.
150, 390,
Yeah.
510,
Yeah.
750.
Okay. Root 3 by 2. Now what's your root 3 by 2? Tell me. Root 3 by 2 is how much? Point. What did you get? On your calculator, just check what is per root 3 by 2. So 0.866. So 0.6, 0.7, 0.8. So here basically. Somewhere here. Almost 0.9. Correct? So how much will that be? This values. How much is that? This is 30.
70,
So 60, na?
60,
60,
110,
120.
20. Sorry.
Then this is 60.
590, 390.
No, this is 60, no? 420.
Okay, 420. 480.
450 plus 30, 480. Correct? Then this is, but it's only up to 720. Sorry, you don't write that. Now use the graph to estimate theta when for 0 degrees theta is between 0 and 720, for which sine theta is equal to 0.3. See, erase this then. You must use a pencil in exams. Huh? So 0.3 is 0.1, 0.2, 0.3 here. So what will this be? 15. So writing it coming in between, no? This. See, this is 90 till here. So this each of this is 30. Basically, each is 30, so 15. 15. Then this will be how much?
165.
Yeah, 180 minus 15, 165. Very good. This would be 375.
375.
This would be 540 minus 15.
525.
Then this will be 720 plus 15.
525.
735.
7.
Yeah. Find the intervals in which sine theta is positive. When is it positive? Positive is when the graph is above. This is positive.
0 to 180.
So 0, you can use interval notation. 0 to 180, correct? Or
365.
360, 540.
Or 540 to 720.
No, 540 to 720 is negative. But that's it. This we don't have to take. So no need. You have to only think. You have to only take that.
540, 720.
Negatives from 180, negative is positive. Negative is 180 to 360. Correct? Or